We're going to briefly review the properties of exponents today. Basic things about how to combine powers when they're being multiplied or added or subtracted. If you're multiplying two of the same base, so if I have like x to the third times x to the fifth, I add those powers up and I get x to the eighth. And this even works with numbers. If I had 2 to the third times 2 to the fourth, that would become 2 to the seventh, which is 2, 4, 8, 16, 32, 64, 128. With division, I subtract them. So like a to the fifth over a to the second would become a to the third. I do 5 minus 2 to get 3. You can always do what I say is when in doubt, expand it out. A to the fifth means you have 5 a's. A to the second means you have 2 a's. A over a is 1. A over a is 1. Those two things cancel, and you're left with just a to the third on top. Power of a power means to multiply. If I have y to the third to the fifth, that becomes y to the 15th. If I wanted to, I could write out y to the third 5 times to expand it out, but you get the idea. There's going to be 15 y's there. And here, this power of x is going to go, I don't know why it has x, it's supposed to be a c. That power of c is going to go to those other powers down below. So this is a c here. It becomes, like if I had 2 over x, and it was x to the third, and this is all to the fourth, it'd become 2 to the fourth, which is 16, 2, 4, 8, 16, over x to the 12th. I basically did 2 to the fourth over x to the 12th to get there. All this stuff should be reviewed. This last bottom stuff is what causes the problem. An example here, if I have x to the third and y to the fourth, this is all to the fifth, that becomes x to the 15th, y to the 20th. Be really careful if there's a number in there, though. 2 to the 2x to the third to the fourth becomes 16x to the 12th, because I did 2 to the fourth and then x to the 12th. Anything to the 0 power is 1. Well, anything except for 0. 0 to the 0 power is a big argument. But anything else to the 0 power is 1. Like if I have x to the third over x to the third, that becomes x to the 0. And x to the 0 is just 1, because this was something divided by itself. And something divided by itself is 1. So anything to the 0 power is 1. Those are all ones that, for the most part, we're familiar with and should be able to handle. It's the negative powers that start to cause people problems. A negative power is really doing a reciprocal. It's taking a fraction and flipping it over. So if I have 3 to the negative 1, that's really 1/3. Or 2/3, all to the negative 1 is 3 over 2. And, to get really confusing, 2/3 were just that 3 is to the negative 1, but the 2 on top isn't. Would become 2 times 3 to the positive 1. The negative power flipped, but the top power didn't change, and this would just be 6. So to do it with variables, like x to the negative 3 becomes 1 over x to the third. And 2 over x to the negative 5 becomes 2x to the fifth. Because right now just the x is to the negative power. The 2 is not brought to a negative power. Negative powers don't change signs. So it's like 3 to the negative 1 didn't become negative 3. When I had 3 to the negative 1, that does not become negative 3 or negative 1/3 or anything like that. It just takes the fraction and flips it over. A negative power flips a fraction over. So here, that's a negative c. The negative's really faint. You can barely see it. But the whole fraction got flipped over because of the negative power. That's why the x's went to the bottom, and you had x to the ac on the bottom and y to the bc on top, because the stuff that was on top went to the bottom, stuff on the bottom went to the top. Here's some quick examples of these properties. This first one will become 2 to the third x to the sixth, which is 8x to the sixth. I'm just simplifying. A nice thing about these is you could always check in your calculator. You could just just type in 2x squared to the third and see what you get. Now that came out to 0, which means that the calculator is storing x as 0 right now. Right now the calculator thinks x is 0. So using x can be really dangerous. So let's not do that. Let's pick something else. Let's just say, let's just plug in like a 4 for x. If I do 2 and then x is now 4, so 2x squared. And do all that to the third. I get a really big number. And I'll check this one here. I'll do 8 times 4 to the 6th. I get the same big number. So you can actually check all your answers if you plug in a number for your variables, for your letters, and see if it works out true or not. Never plug in -1, 0, or 1. Always like 2, 3, or bigger. This had everything to the third power. This just has x to the third power. So this becomes 2x to the 6th. Notice the difference in those two problems. They're very different. Here I can simplify. 3 over 6 becomes 1 over 2. I don't subtract these powers. I divide them. I'm doing the fraction 3/6. And x to the 5th over x to the 9th becomes x to the 4th on the bottom. So it's 1 over 2x to the 4th. Here's how I think about this. One is like there's 5 x's on top. There's x to the 5th. There's x to the 9th, 1, 2, 3, 4, 5 x's canceled, so we're left with 4 x's on the bottom of the fraction, and we just have a 1 on top because x over x is actually equal to 1. Or you can think I'm doing 5 minus 9. And 5 minus 9 is -4, which is an x to the 4th on the bottom. Either way, you get 1 over 2 x to the 4th, or 1/2 with an x to the 4th on the bottom. Here, I like to deal with negative powers first. So like this negative power is going to take this whole parenthesis and move it to the bottom of the fraction. So I'm going to have 3x squared y to the -3rd over 2xy to the -5th. Now to the positive second. All that I just did was play with that negative power. Not even the 2, just the negative. Just that negative. Took the fraction, the parenthesis on top, and moved it down to the bottom. Now I'll keep going. I'm going to simplify parentheses first, so I deal with this power. So I'll have 3x squared y to the -3rd over 4x squared y to the -10th. And that should be 4x to the 4th, actually, excuse me. Now the parentheses are all gone, and I've dealt with all the major, powers affecting everything. I deal with the like terms and common bases. 3/4 just stays 3/4. Nothing can happen there. There's 2 x's on top and 4 x's on the bottom, so it's x squared on the bottom. And I'm really doing -3 minus 10. I'm going to deal with these y powers now. I'm looking at this. I have this. There's a few ways you can do this. One is the negatives flip the fraction. The y to the -3 on top became +3 on the bottom. Y to the -10 on the bottom became +10 on top. And then you simplify and get y to the 7th. Or you can just do -3 minus -10. Because remember, when you do subtraction, when you do division of powers, you subtract them. I'm doing this property here. So I'm doing -3 minus -10. This way is kind of dangerous because a lot of people forget to make that a +10. Oops, +10. And that gives you y to the 7th. And that's what's going to go here. 4x squared, y to the 7th. Negative power is going to be where the tricks, the issues come up, so pay attention to those, and we'll move forward with them in a little bit.